In this tutorial, we're going to learn how to perform a Wilcoxon rank sum test in Stata. So for this example, we're going to be using data from the Digitalis investigation group. And below this video, there's a handout that explains more about this trial. And I'll encourage you to stop the video now and read that document and then come back to the video. It'll give you a better background about the trial. So the trial was a randomized, double-blind, multi-center trial with 300 centers in the US and Canada participating. So the purpose was to examine the safety and efficacy of digoxin in treating patients with congestive heart failure in sinus rhythm. So the main paper can be found in the New England Journal of Medicine. So in the paper, the Wilcoxon rank sum test was used to determine if there were any differences between the two treatment groups in the number of hospitalizations. So one group got the treatment, one group got placebo, and they want to see if there's any differences between the groups in the number of hospitalizations. So why don't we go ahead and open the data set in Stata, the dig.dta dataset, and let's examine the number of hospitalizations by treatment group. So the two variables that we're interested in are number of hospitalizations, NHOSP, and treatment group, which is spelled TRTMT. Now, to get the histogram of number of hospitalizations by treatment group, type in the following command, hist NHOSP by treatment. So as you can see, the number of hospitalizations are similar. The distribution of the number of hospitalizations are similar between the two groups, and they're non-normal and they are right skewed. So we know we have non-normal data, so we can't use a t-test because the assumptions of the t-test don't hold. So we're going to use the Wilcoxon rank sum test. Now, does this require any assumptions? Yes, there are two assumptions, and number one, the two samples must be independent. And two, the distributions in the two groups should have the same shape. Now we saw that when we looked at the histograms, they did indeed have the same general shape. Now what are the null and alternative hypotheses for the rank sum test? So the null hypothesis is that the median number of hospitalizations for the two treatment groups are equal. And the alternative is that the median number of hospitalizations for the two treatment groups are not identical. Now since we assumed the two distributions have the same general shape, a difference of medians would simply imply that the two distributions have the same shape, but they're only shifted in location. So what we're saying is the null is that they have, the same general funky shape, while the alternative is that they still have the same shape, but it's just shifted by some constant. Now let's go to Stata and let's perform a rank sum test. So let's use alpha equals 0.05. Let's go ahead and perform this test. And the command in Stata is very simple. It's just rank sum, one word. So type in the following command, rank sum NHOSP by treatment. So you'll notice that Stata gives us a table of the number of observations. See, we have 3,403 people who got placebo, 0 is placebo, 1 is treatment, and 3,397 people who got the treatment. Now Marcello in his slides showed you how the rank sums are calculated. I'm not going to go through that for all 6,800 patients, but these are the rank sums. These are the rank sums here. This is what we expect under the null hypothesis. So we don't need to be concerned with these unadjusted variance, and adjusted for variance. What we're concerned at is our z-value, which is 2.491, and our p-value is 0.0127. So since our p-value is less than 0.05, we're going to reject the null hypothesis. Thus, we conclude that we have evidence that the median number of hospitalizations differ by treatment group. In fact, we have evidence that there are significantly more hospitalizations in the placebo group. And if you take a look at the paper, you'll notice that the p-value reported in the paper is the same as the p-value here. So we indeed did replicate the results from the paper.